Everything around us is made of matter, and matter is nothing more than elements combined in different ways to give us different kinds of molecules, molecules that make up trees or tables or computers or you and me. Our question then is, how do different atoms interact to make up all this stuff? We're going to see in a little while that atoms interact because of, well, valence electrons. If you remember back to atoms and isotopes, we have three subatomic particles: protons, neutrons, and electrons. The protons and neutrons are found inside the atom in the nucleus, and the electrons are on the outside. Well, the electrons on the very outside are referred to as the valence electrons, and since they're the ones farthest out, they're the ones that are going to interact with other atoms. The whole goal of an atom is to get full valence electron shells. There are going to be a couple different ways this occurs, and we'll talk about both of them briefly. If we look at a couple of atoms, we have a chlorine atom on the left and a sodium atom on the right. We have the protons and neutrons in the nucleus. The number of protons, we'll recall, gives us is the atomic number, and it tells us what the atom is. If I have 17 protons, I'm chlorine. If I have 11 protons, I'm sodium. One of the main ways that the number of protons determines the identity of an atom, an element, is it also determines the number of electrons, or that is, if I'm sodium with 11 protons, I also have 11 electrons. And if we start to count the electrons in the shells outside the nucleus of sodium, we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And this electron out here is the valence electron in the outermost shell. If I come over to chlorine, I've got 17 protons, which means 17 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Now, you probably noticed as we went through and counted the electrons that they're not just randomly arranged in the shells, but there seems to be some sort of order. That order is referred to as the octet rule or the rule of eights. Nitrogen is an atom with 7 protons, 7 neutrons, but if it has 7 protons, we know it also has 7 electrons. And if I start to arrange the electrons in the orbitals, in the shells, around the nucleus of a nitrogen atom, I first put, I see 7 protons, 7 electrons, there's the first shell, 2 electrons in the first shell, and as soon as I get 2 electrons in the first shell, it's full. I can't fit any more electrons in this shell that's closest to the nucleus and that I always start to fill first. So I jump to another shell, which is now my valence shell, and 3, 4, 5, 6, 7 electrons. This second shell can hold up to 8 electrons, thus the rule of eights. And if I had gotten to 8 electrons in the second shell, it would be full, and I'd have to jump to the next shell to put any more in. Let's try another. The silicon is an element with 14 protons, 14 neutrons, but the important thing for us is if it has 14 protons, it also has 14 electrons. In the first shell, I'm able to fit 1, 2. That electron shell is now full, so I jump to the next shell, 3, 4, 5, 6, 7, 8, 9, 10. Now I have 8 electrons in the second shell. I'll have to jump to the third shell, 10, 11, 12, 13, 14. And now I'm done. So I always put electrons in this ordered arrangement where the first shell closest to the nucleus fills first, always, and it can only hold 2. The next shell can hold 8, it fills next, and then the third shell can also hold 8. We're not going to go past element number 18. So we don't need to worry about having beyond 3 shells. If you start to get concerned about that, just hold on, you'll get it in chemistry class. But for us biologists, 3 shells is going to be plenty. So the next thing is, okay, I have an understanding of how the electrons are going to be arranged around the nucleus, but how does that arrangement tell me how that atom interacts with other atoms? Oh, I remember. It's the valence shell that's important. That's the one that's on the outside. And valence shells want to be full. And everything an atom does is geared towards filling up that valence shell. There are 2 primary ways we can fill the valence shell, and we're going to start with the complete loss or addition of electrons. So we're back to our friends sodium, which is now on the left, and chlorine, which is on the right. If you look at sodium, it's got 1 lonely electron in its valence shell, and chlorine has 7 electrons in its valence shell. So chlorine, if it could somehow grab 1 more electron, it would have 8 in its valence shell and be happy. And sodium, I suppose it could gain 7 electrons, but it's a whole lot easier to lose 1 electron. And look, if sodium loses that electron, well, what was its valence shell is now gone, and the shell inside is its valence shell, which has 2, 4, 6, 8 electrons. It's full, it's happy. And now chlorine has 2, 4, 6, 8 electrons in its valence shell. It's full too. These are 2 happy, well, they've gained or lost electrons, and they're no longer referred to as atoms. As soon as an atom gains or loses an electron, it's called an ion. And the consequence of becoming an ion is that you are now electrically charged. If you go back to the video on atoms and isotopes, you'll remember that protons and electrons were charged subatomic particles, protons being positive and electrons being negative. If we look at the sodium ion now, it has 11 protons, or plus charges, but it only has 10 electrons since it lost 1, and gave it to the chlorine atom. So 11 pluses, 10 minuses, add them together, I wind up with a net charge of positive 1, and I'm not just an ion, I'm a positively charged ion called a cation. If we go and look at the chloride ion now, we see, well, it still has 17 protons, but now has 18 electrons. 17 pluses, 18 minuses. That gives me a net charge of -1, and I am called a ion. Negatively charged ions are called anions. And the next really important consequence of this complete losing and gaining electrons to form cations and anions, positively and negatively charged ions, is that I've got this sodium ion that's positive, this chloride ion that's negative, and opposite charges attract. And I no longer have 2 individual elements. I've chemically bound these elements together because of their opposite charges to form an ion. And the bond that's formed between them is referred to as an ionic bond. Ionic bonds result because we completely lose and we completely gain electrons to form ions, which then can be attracted to each other. The next kind of bond, called a covalent bond, we'll discuss in the next video.